Okay, I'm back, and now we want to review lesson number 17 for the Unit 3 exam. So this one is on the birth of stars, and then this should be chapter 13 out of your textbook. And the first thing we talked about was, what is outer space like? So what I want you to get from this is it's cold. So in outer space, you have a temperature of 4 Kelvin, which is kind of surprising that there would be any temperature at all in outer space when you're so very far away from stars. But there is a certain amount of heat in outer space from starlight, and then it's a remnant of the Big Bang, which we'll talk about in unit number 4. Okay, the density of outer space is very, very low. Approximately 10 atoms for every cubic meter of outer space. And you can see that the density of the air in a room is much, much greater than the density of outer space. And then you should know what outer space is composed of. So outer space is composed of 99% gas, and that gas is hydrogen and helium, and then about 1% dust. And that dust is composed mainly of silicon and iron. Okay, then you need to know what a nebula is. So a nebula is a big ball of gas that can collapse to make a star, stars. So what are some properties of these big balls of gas that are floating around in outer space? Well, they have a temperature, now this is important, of 10 to 30 Kelvin. Now it's not important that you know the number, but notice it's bigger than 4, and it's just enough to cause problems. Because what we want to have is, we want this ball of gas to collapse because of gravity and then turn into a star. So as long as it's got this temperature of 10 to 30 Kelvin, that's going to be making the atoms of the gas be moving around. They're going to be moving around at different speeds and in different directions. And so that is going to be enough to push this gas cloud and try to make it expand. Gravity is trying to pull it in and crush it and turn it into a star. So the fact that this thing is slightly warm is actually a bad thing. It's keeping gravity at bay. So we call this thermal gas pressure. It's the pressure exerted by the molecules of gas because they're at a certain temperature. The greater the temperature, the greater the thermal gas pressure is going to be. The density is higher than outer space. That's good, because the greater the density, the greater the mass, the greater the mass, the more gravity, and gravity is what's going to pull it in and turn it into a star. So another thing I'd like for you to know is that dust tends to block visible light. So that's why at night it's dark, is because the light from all the stars that are surrounding us, most of that light doesn't make it to Earth because it's being intercepted by dust. But there is a kind of light that very easily penetrates dust, and that's going to be infrared. So if an astronomer wants to observe stars without seeing the effects of dust, then they observe the stars in infrared light. So this is an explanation for it involving the diffraction of different kinds of light caused by the dust particles. Don't worry about it. So that's not going to be on the exam. Okay, similarly, there are 3 different kinds of nebulas. So you have a dark nebula, the Emission Nebula, and then the Reflection Nebula. And so I'm not going to concentrate on that. So let's just skip this thing here, but notice that there are different kinds of nebulas. Okay, this is very important. So what are the forces acting on a nebula? So the first one is going to be, what's the forces that are pulling the material in? That's going to be gravity. Okay, then you have the forces that are trying to push outwards. And you can see one of them is thermal gas pressure. So that's what we were just talking about. The fact that the gas is at a certain temperature means that the molecules are moving at a certain speed, and the greater the temperature, the greater the speed, and the greater their pressure is going to be. So that's one thing that's going to keep this cloud from collapsing. Another thing is magnetism. So I know it's almost impossible to read on there, but I do have a caption underneath that picture there. It's a website that you can go to that shows how electricity causes magnetism and how magnetism can repel other magnetism. So certain parts of this cloud are going to be magnetic, and they're going to repel other parts of the cloud that are magnetic. Okay, another one is centrifugal force. So we already covered this in unit number 2 when we said that if you put a rock on the end of a string and you go around your head with it, okay, that rock is going to feel like that rock is moving outwards, and that's actually the centrifugal force, but that's caused by the centripetal force, and it has to do with the speed at which it's going around and the radius, the distance that the object is from the thing that it's going around. And so we talked about that in unit 2, but the point is that these particles in the cloud are also rotating very slowly, and so that provides another force that keeps gravity at bay. Okay, then the final one is turbulence. So these particles in here are kind of random, and so they generate winds inside of this cloud. And so that turbulence also can keep the cloud from collapsing. All right, so let's take a break here, and then when we come back, let's talk about how stars are born.